question number 6. Here we go. Question number 6 says, in the diagram, we have two graphs. There's a cos graph and there is a sine graph. So the cos graph, where's the cos graph? The cos graph is the one f. Is the graph of f, right? So let's do this. This is f of x. And then this is g of x. You see, g of x. Yay. Let's just leave that one alone because it looks weird anyways. So with that being said, it says these are drawn below between negative 180 and positive 90. The first thing they said here for 2 marks, they said for which of the values of x between negative 180 and 90 will this expression be bigger than 0? So you can see, yeah, I feel like we always bump into these kinds of questions. So, hey, yeah, let's just try and understand what they mean. Fortunately, if you have a picture, right, these questions are very simple. This question is just telling you have two things being multiplied together. You see, one of them, it's y values of f. The other one is y values of g. They're just asking us, where will this left side of our inequality symbol, where will this left side be bigger or equal to 0? So it's just asking, where will this left side be a positive number or equal to 0? So for this left side to be a positive number, you need to be multiplying by 2 negatives, or you need to be multiplying by 2 positives. That's the only way you can have this left side being bigger than 0. Where it's equal to 0 is easy. So let's just try and figure this out first. So you just want to work out, where will the y values of f be negative while the y values of g are also negative? So in your picture, you just want a scenario where both graphs have negative y values. And we don't have any portion of our sketch where both graphs have negative y values, you see, because this is our x-axis. This has y values here, but the graph of f does not also have y values here. So there's no point, there's no scenario where both have negative y values for the same x. There's no scenario like that. But then the question here, there is a scenario where both have positive y values at the same x values. And that's happening from this specific x value. This specific x value where these two graphs are meeting each other. Or not necessarily that only. It's actually from here, from negative 30. From negative 30 all the way until 90, right? You can see this graph has positive y values. And then the other graph from negative 30 to 90, it also has positive y values for those same x values, you see. So it's starting from here all the way until here. You see, that's a scenario where there's positive y values and positive y values as well. So in terms of giving an answer for 6.1.1, where will this be bigger or equal to 0? Firstly, it will be bigger than 0 between, let's say here, x is an element of from negative 30 to 90, right? Negative 30 until 90. So now you have to decide whether to put square brackets or round brackets. So obviously for the 90, we're going to put a square bracket because specifically at 90, this is a positive, this is also a positive. And then specifically at negative 30, we're also going to put a square bracket. The reason for that is one graph is equal to 0 here, you see. So if n of these is 0, it will be 0 times something, you know, and that does qualify for a scenario where they say bigger or equal to 0, you see. Because for something to be equal to 0, if this side is going to be equal to 0, one of these have to be 0 at some point. And one of them is equal to 0 specifically at negative 30. So that's why negative 30, we're putting a square bracket over there. So that's why this is just a 2-mark question, because as long as you know how to interpret the question, you will be able to give your answer. So the next one, though, they're saying for which values of x between negative 180 and 90 will g of x be equal to negative 90? G of x, where is g of x? G of x is this graph here, right? So this is 2 2 sine and then x plus 30. Let's see here. G of x is equal to 2 sine. Wait, what? 2 sine x plus 30. Whoa. Awkward. X plus 30. Now, this is just a 2-mark question. They're asking you, where is this graph equal to -1? So, I mean, we cannot necessarily see it from the image. So we have to, looks like we have to work it out algebraically. But let's see. Where is this equal to -1? Let's just try and work this out. But for 2 marks, I'm obviously thinking, but do we really have to work it out, or we should just be able to see it from the sketch? And we should just be able to see it from the sketch, actually. And here's why. So what you want to actually understand about these images, right, is you want to be able to interpret them based on what the standard images look like. So what has happened here is, this is just a sine graph, you see. It's a sine graph. Now, a standard sine graph looks as follows. Between 0 and 360, it looks like this. On the other side, it will look like this, between 0 and minus 360. So the key thing, though, is in the middle here, we have -180, positive 180, and then here we have 360. So the issue now is, this graph has an amplitude of 2. You see, so up here you have a +2, down here you have a -2. Now they're asking us, originally, right, if you look at it nicely, it's actually a bit difficult for us to determine where this graph is going to be equal to -1. So I think algebraically seems like the only way, unless there's another way, but without worrying too much about that, I mean, like, let's just do what we can see works. Because this is a standard sine graph that looks like this, sine 2 with x here. This is this image. The moment you move it 30 degrees to the left, that's where it will look like this, you see. But for now, let's just see where this is equal to -1. Solving it algebraically, we can firstly divide both sides by -2. So we have half here with over 2. I mean, divide by 2, I mean. So dividing by 2, we're going to have here sine x plus 30. To get rid of the sine, we have to do some reference angle shandies here. Funny enough, I always end up using the reference angle and then doing some what you call general solution stuff to eventually get an answer. But before I even carry on, for some odd reason, I keep coming back and asking, but why is it just 2 marks? If it's just 2 marks, we shouldn't be doing too much, actually, you see. So before I do carry on doing too much, is there anyone that sees, I don't know, like something easier to do with this question? Because what we do know is that here, it is definitely -2. And then here, if we trace it nicely, I mean, like, we could guess and say -60, but hey, it's an expensive guess, that one. Because why guess when you can actually just get, the real McCoy, So for a 2-mark question, based on the sketch, I would have said x is equal to -60. So all we can now just do now is, let's see if algebraically we end up with -60 as well, So carrying on from here, I always do this. If I'm going to do shift or whatever, I always do it in terms of getting a reference angle, meaning I always use this as a positive. And let's see here, we're getting a reference angle. Shift this is our reference angle. Reference angle is equal to shift sine with a half, and then shift sine with a half is going to give us a 30, definitely. So let's see here, shift sine 30. Did I put? Yeah, shift sine, shift sine a half. It's going to give us a 30, right? So the reference angle is a 30. And we know that since we were working with a negative, we should work in the second and the fourth quadrant. in the second quadrant, we might only need to work with the second quadrant though, because I mean, like, this is going too far, because this is going to be like 360 minus the reference angle. And I mean, like, we are only ending off at, like, you know, we're working with this side here where there's, like, you know, negative numbers and all that. So here, let's see. This is the quadrant 180 minus the reference angle. So 180 minus our reference angle, that's in the second quadrant, you see. So here we're going to say, therefore, we have here the x plus, shift and this, yeah. The x plus the 30 is equal to 180 minus the reference angle. And then what are we going to have now? Plus k 360, k is the element of integers. Do this here. This definitely feels like overkill because it is. We already did what 2 marks would get us, which is the negative 60 as mentioned. K is the element of integers, right? Carrying on from here, we're ending up with, what are we ending up with? We're ending up with, if the 30 goes to the other side, you're gonna have 30 here, it's gonna minus that 30. So you're gonna have here 180, minus 30, that's gonna be minus 60, and then you're gonna have the positive 120, which is kind of scary because, yeah, that does not look, oh wait, that's the graph of G. Bugger. Yeah, no, it is the graph of G. So this graph of G comes like this, goes up, and then 120. Yeah, it says here somewhere at 120 it's gonna come back down to -1, but that doesn't look likely at all. Because let's see, this is like at 60. So it's like 1, 2, 3. Does anyone spot anything fishy or crazy or wrong? Because let me just add this person. Just add this person over here. Where is this person? Zoop. Admit. Because the more I write down, the more I'm like, 2 marks. Aye, man. Nah, fam. But then either way, right? The other thing that I also spotted was this is equal to -60, right? But then the other side would also have a y value of -1. So you see, between -60, this would end up at specifically -180. So the answers that I'd put is x is equal to -60 or x is equal to -180 based on the sketch. But algebraically, it doesn't seem like it's making sense. I don't know why. Let's see. Got a reference angle here. Reference angle is equal to 30. In the second quadrant, we said here it's 180 minus the reference angle. This goes to the other side. It's gonna be -60 plus k360 over here. K is the element of integers. Why is this thing not writing now? Whoa, oh, it's writing in black. Plus k360, k is the element of integers. But I think with this one, let me just leave this one here for now, you know, because I think I'm just gonna waste time. I'll put a question mark over this. And then for now, we will stick to our -60 and -180 on the basis that this is a 2-mark question. They're asking us where the graph of g of x is going to be -1. We have our sketch. It looks super duper nice. And we have 2 values that we can easily see with our eyes. You know, if we had to do any funny calculations, this question would be worth a bit more. So for 6.2, it says the axis is moved 90 degrees to the right. Determine the new equation of the graph, originally called f, in its simplest form. What? The y-axis is moved 90 degrees to the right. Determine the new equation of the graph, originally called f, in its simplest form. This question is quite interesting because in the trigonometry course, there's a question just like this. When I say there's a question just like this, I mean there's a question that definitely talks about the axis of symmetry being moved. Whether I think it was I'm not sure which one was moved, but something was definitely moved. Let me add our fallen comrade Hiso. So the idea with this kind of a sketch is, or with this kind of a question, we actually have to get the sketch and paste it down here so we can visualize what is going on. So let me crop this here. And then let me work on, let's see, let's read again. So they're talking about the y-axis being moved. So remember, the y-axis is over here. Let me make this bigger. Make this bigger, right? There's the y-axis. Y-axis. So this y-axis is moved 90 degrees to the right. So if it's moved 90 to the right, you have to be conscious now. If the y-axis is moving to the right, logically speaking, what is actually happening is, what's the easiest way to put this now? If the y-axis moves 90 degrees to the right, it is as good as though the graph is being moved 90 degrees to the left. The reason why I'm saying it like that is because, I mean, like logically speaking, right? I mean, no. Let's not overcomplicate it. If the y-axis now comes here, right? I mean, it doesn't make any sense, because your y-axis and your x-axis, they always meet each other at 0 coordinate 0. You see, so when they say stuff like this, they're just gonna make you think outside the box, So they said if the y-axis is moved 90 degrees to the right, determine the new equation of the graph, originally called f, in its simplest form. So if the y-axis moves 90 to the left, right, it would be somewhere like there. Now, the one thing you want to recognize is that all you want to do is you want to think to yourself, if your image had an x-axis here and your image had, if it had a y-axis here, right, and it had an x-axis over there, logically speaking, an x-axis and a y-axis have to meet at 0 coordinate 0, So what you have to think to yourself is, if your y-axis is moved 90 degrees to the right, it is as good as moving your graph 90 degrees to the left, you see, because for you to produce an image that looks like this, you see, your graph would need to move 90 degrees to the left, because the y-axis and the x-axis always have to meet at 0. So I know this is one of those questions that, you have to look at it twice, for you to get the logic behind it. Because if they're telling us the x-axis, the y-axis moves 90 to the right, like logically speaking, if it moves 90 to the right, they're just gonna tell us that this is what the image we would be seeing, right? We would be seeing a y-axis over here, and this is an x-axis. But then the issue is an x-axis and the y-axis always meet at 0, So if this is 0 here and your image does this thing here and your image does this thing over there, for you to have a scenario like that, that can only happen if our graph moves 90 degrees to the left, So before I carry on, does everyone understand what we are saying when we're talking about our image eventually looking like this, where there's an x-axis here? There's a y-axis over there, there's an x-axis there. This is going to be technically 0, -30, -60, -90, going on and on and on. Does everyone understand that logic?
Yes.
Yeah, because if the x-axis if the y-axis moves, it moves with the numbers there, you see. So the idea is, if that's the image, they're just asking us, for us to have an image like that, logically speaking, our original graph of f here, the f image that we're seeing here, if you're going to have 0 here, -30, -60, and -90 like that, it means that this graph would what you call our graph of f would need to move 90 degrees to the left. So if f was moved 90 degrees to the left, its new image, or if its new equation, right? We just need to take it from this, you know, because the original f of x, right, looks like f of x is equal to negative cos x plus 1. But then if this graph was moved 90 degrees to the left, then it means that your new graph would be equal to negative cos x. Let me just do this here. Negative cos. And then here we would have to have, since it's moving to the left, we need to have plus x. I mean, plus, we need to have x plus 90, x plus 90, and then plus 1, like that. The mark allocation here is just a 2-mark question. The only thing that's annoying me is the fact that they said here, determine the new equation of the graph, originally called f, in its, the original name is f, but then the new equation. Yeah, so the new equation, we can just label it y. Y is going to be equal to this thing here, you see. Y is going to be equal to negative cos x plus 90 plus 1. So obviously, since we have x plus 90 here, we can actually write it flipped around so that we can see that this is actually just going to turn into something that is a sign. It's because 90 plus lands us in the quadrant where sign is a positive, you see. So here, even though we change this to a sign, we have to be careful here. Even though we change this to a sign, we have to put a minus there because you always choose this based on where you're coming from, see. And then plus 1. And then here, these two are added together. It's going to give you a positive sine x. I mean, these two multiply together, it's going to give a positive sine x and then a plus 1, like that. This is what your new equation would look like. And that will give you all your marks. Ding, ding, ding. So, any questions on this? Now is your time to shine. But I believe we have gone through all that there is to